Good afternoon, students. Welcome to the next session of our subject, that is concrete technology. And we have started our unit number 4, that is dealing with the desired properties of the concrete. Okay, so which properties of the concrete we are going to study as far as this chapter is considered. So I think in our last session, we have discussed the syllabus as well as the introductory part regarding this particular topic. In this particular chapter, we are totally deals with the hardened concrete. Okay, in our chapter number 3, we have completed the part of discussion that is with respect to the fresh concrete. Now, in chapter number 4, we are going to discuss the hardened concrete. Okay, we are going to discuss the hardened concrete. So, what are the properties of the hardened concrete? How we are going to assess the quality of the hardened concrete? That means, what are the different tests that we need to carry on your hardened concrete? So that part we are going to study in detail about the on this particular chapter. Okay, hardened concrete and the properties associated with this. So which things we need to consider? We have started our discussion with the definition of the word. What is hardened concrete? Okay, what is the hardened concrete? The concrete which has lost its complete plasticity, that you called it as the hardened concrete. Correct. In simple words, if you want to define what is the hardened concrete, hardened concrete is nothing but that concrete which has lost its plasticity. That means the concrete has achieved certain strength, minimum strength it may be, or it may be the certain strength, certain durability it has achieved, and it has lost its plasticity completely. So that concrete we can call it as a hardened concrete. So in the hardened concrete, what properties we are going to check, or on which things we are going to assess the hardened concrete or hardened concrete. So the properties we are going to study, some of them I am going to highlight here, is nothing but the compressive strength, then durability, impermeability, and the dimensional changes. Okay. So the first point that we have started in our discussion is nothing but the strength of the concrete. What is the strength of the concrete? Can you define the definition once again? The strength of the concrete is nothing but it is the ability to resist the stress, whatever the stress which is acting on that concrete body. So the ability of that concrete to resist the stress without failure. Okay, so that ability or that capacity of the concrete to sustain the load which is acting on it before failure, it is very important for us. Before failure, that ability of resisting the stress or of taking the load or whatever it may be, you can call it as that strength of that particular concrete. Specifically, they have used the word as ability to resist the stress. Now, what is stress? Stress is nothing but load acting on a concrete body with respect to the area or to the given area. Load divided by area, you will get the stress. Okay, load divided by area, you will get the value for the stress. Now, ability to resist this, whatever the load which is being sustained by the body before its failure, that ability is nothing but its strength. Okay, now how it is, again I am trying to simplify it. Suppose you have taken one piece of a floor, tile floor, okay, floor tile, sorry, at your hand, and when you have taken that floor at tile, sorry, at your hand, you are trying to apply some kind of load here. ठीक आहे, तुम्ही त्याच्यावरती काहीतरी लोड अप्लाय करता. ठीक आहे, that particular tile is having its own capacity to sustain some kind of load. It may be 5 kg, 10 kg, 15 kg. And ज्यावेळेस तो लोड जास्त होणार आहे, त्याच्या कॅपॅसिटी पेक्षा जास्त होणार आहे, what will happen? The tile will break down. Correct? The tile will break down. ठीक आहे. As like in our concrete also, concrete is going to gain the strength, concrete is going to take the load. Okay, what are the different types of the loads? I think now you are diplomats, so you know much better. Okay, so if you just take which type of load is acting on a concrete body, if you want to highlight some of the loads, is nothing but the self weight of that concrete structure itself. Okay, the concrete is having its own unit weight. It may be the concrete is of lightweight concrete, it may be of normal weight concrete, or it may be a heavy weight concrete. That concrete is having its own unit weight. Correct? What is the range of that unit weight of the concrete? Can you define any range? Do you have any knowledge about this?
25 kilonewton.
What will be the range of
25.
that concrete? Unit weight of the concrete. See, for lightweight concrete, the unit weight is between 18 to 22 kilonewton per meter cube. Okay. Then for medium weight or for the normal weight concrete, the unit weight is nothing but 22 to 26. And for heavyweight concrete, the unit weight is in the range of your 26 to 30 up to. Okay, kilonewton per meter cube, or you can take it is in kg per meter cube also. Okay. No, that is, these are some factors, as you have mentioned. Sir, there are different grades of the cement we are using. It may be 33 grade, it may be 43 grade, or it may be 53 grade. So, the strength of the concrete, the unit weight of the concrete, definitely it will also play a vital role. We have to consider the grade of the concrete also. That is, it may be of OPC 43 grade, it may be of OPC 53 grade. Again, the unit weight also depends on the size of coarse aggregates that you are using, or size of aggregates. Okay, whether you are using lightweight coarse aggregates, whether you are using heavyweight coarse aggregates, or whether you are using conventional weight aggregates. Okay, so there are some factors. We are not going detail about it. Just what I want to highlight to you. Okay, some load is acting. What that load? First load is nothing but the self weight of the concrete. Okay, concrete just स्वतःचा weight. Second load is nothing but the live load which is acting on that concrete surface. The best example, now you can see the floor, tile floors are there. Okay, and you are just standing on the tile floors. Correct? On that particular tiles at your home. So your weight is acting on that particular tiles, and it is again being distributed to the concrete body directly to the subgrade soil which has been there. But the load transformation is there. Your weight directly comes on the tile, then through the tiles it will pass through the PCC bed or whatever the DPC layer you have prepared, or whatever it may be. Sorry, plinth levels, different layers are there, whatever it may be. So some load is acting, that is your live load. It may be 60 kg you are having weight, you are having 90 kg weight. So your load is acting. Now, if you just take the example of classroom, benches are there. So these benches are again acting some load on the tiles or on the floor. Again, that load is being transferred from floor to the subgrade soil. So load transformation is there, load is acting. Next load, wind load. You have studied this part in your design of steel structure. Okay, wind load is there, snow load is there, impact load is there. So there are different types of the loadings which are acting on the body. Okay, and the concrete has to sustain all these particular loads. Okay, with respect to the area. So before failure, whatever the load sustained by that concrete surface, that is its strength. Okay, I hope now no one will going to forget what is the strength of the concrete. Okay. So the compressive strength, in the strength of the concrete, the compressive strength is one of the important property of our concrete. In some situations, other strength of the concrete also play the vital role, as like your flexural strength, or it may be your split tensile strength. Okay. Now, as far as our road constructions are considered, as I told you in my previous sessions also, in case of road, our more focus is on the flexural strength of the concrete, not on the compressive strength. Definitely, compressive strength must be there. It is the mandatory clause. But along with that, we are going to design our rigid pavements based on the flexural strength. Okay, the flexural strength, it should not be less than 4.5 Newton per mm square. It should not be less than 4.5 Newton per mm square, or whatever the design that we are having. Okay, whatever the design that you are having. So, because we are having one relation between the compressive strength of the concrete and the flexural strength of the concrete. So you can be, by using that relation also, you can assess if you have the flexural strength. Sir, if this is the flexural strength, this will be the compressive strength. We are having one relation. I'm going to tell you. That is the thumb rule also, which we are going to use it. The flexural strength, suppose the compressive strength of the concrete is 30 Newton per mm square. then definitely the flexural strength of same concrete will be 3 to 4 Newton per mm square. Will be 3 to 4 Newton per mm square. That is, you can take in any way, okay, or vice versa relation. The flexural strength of the concrete and the compressive strength of the concrete. What is the relation between these two? Flexural strength, if you have, that means based on that flexural strength, you can assess the compressive strength. 10 to 11 times. 10 to 11 times of the flexural strength you can take it. Okay. म्हणजे जर तुमची कॉम्प्रेसिव्ह स्ट्रेंथ जर 30 न्यूटन पर एम एम स्क्वेअर असेल तर डेफिनेटली त्या कॉन्क्रीटची फ्लेक्झरल स्ट्रेंथ ही कमीत कमी 3 ते 4 न्यूटन पर एम एम स्क्वेअर असली पाहिजे. किंवा एखाद्या कॉन्क्रीटची फ्लेक्झरल स्ट्रेंथ जर 3.5 न्यूटन पर एम एम स्क्वेअर आहे किंवा 4.5 न्यूटन पर एम एम स्क्वेअर आहे, डेफिनेटली द स्ट्रेंथ ऑफ द कॉन्क्रीट इज मोर दॅन 30 MPa. is more than 30 MPa. So that relation is with us. That is one of the thumb rule also we are using on the site. So as I told you, in case of our road constructions, we will design the rigid pavements based on the flexural strength. We are considering the flexural strength because it's a slab-like structure, and you have to count the deflection which is going to happen. The loading will be there, okay, and the load is not the simple load. The truck load or the dumper load, it's a heavy load which that concrete slab has to resist or concrete slab has to take. Okay, so there we will focus more on the flexural strength of the concrete. Okay, and along with that, compressive strength we need to consider. So the strength of the concrete is influenced by various factors that are nothing but type of the cement. Okay, the first factor which can influence the strength, type of cement, shape and size of the coarse aggregates that we are going to use, then concrete mix proportion, moisture content, type and rate of loading. Okay, the factors which were affecting the strength of the concrete. Okay, some factors are mentioned like type of cement. As I told you, it may be your OPC 33 grade cement, OPC 43 grade cement, or OPC 53 grade cement. It will make some impact for your strength gain. Shape and size of the coarse aggregate, whether you are using lightweight coarse aggregate, heavyweight coarse aggregate, rounded coarse aggregate, or angular crust coarse aggregates. Okay, what are their sizes? Concrete mix proportion, whether you are going to prepare your mix design or you are directly what can I say, using the standard proportions which are being given. Okay, in your concrete mix proportion, in your concrete mix design. Then moisture content and the water absorption by the concrete body itself. Okay, again, as I told you, if there are some minor cracks or if there is a more voids percentage in a given concrete, what will happen? The moisture which is present in the atmosphere can penetrate through the voids which have been present. Or if there is a crack which was developed on a concrete body, it may happen that water is get percolated through the concrete body, okay, through that particular crack. So moisture content in a given concrete, again, it will make an impact in gaining the strength. Okay, in gaining the strength, moisture content, your water absorption is also there. Then type and what type of rate of loading is there. What type of loading? Already we have discussed, like your self weight of the concrete, live load, wind load, snow load, impact load, or any other loads which are acting on the body. Okay, so maybe you are just going to compress one concrete structure, so you are going to test how much load it is going to sustain. So type and rate of the loading also we are going to consider. Along with that, some few more factors are there which we are going to consider, like your water cement ratio, gel space ratio, aggregate size, properties of the ingredients, and effect of age of concrete. Okay, now water cement ratio, how it deals with or how it is important for us in getting the strength of the concrete. My dear students, always remember, we are preferring to use the minimum water is to cement ratio. Okay, we are preferring to use the minimum water is to cement ratio. If you are going to add more water in your concrete, what will happen? The concrete is highly workable. The concrete becomes highly workable. And it may happen that there are some chances of segregation or bleeding which can happen in the concrete body. There are some chances of segregation or bleeding which may happen in the concrete body. So you have to select or you have to take the water is to cement ratio as per the mixed design procedure. As per the mixed design procedure. Whatever the water is to cement ratio that you have calculated in your concrete mixed design procedure, that only you have to take. Or if you are going to use some admixtures like plasticizers or like super plasticizers, you can reduce the water is to cement ratio by up to 20 to 25%, maximum up to 30%. So it is very important for us to know about the water is to cement ratio, which you have taken in making or in preparing that concrete mix. Okay, it is very important for us to understand this thing, because higher will be the water is to cement ratio, more will be the workable concrete, more flowable concrete, I can say. And it may happen that it can adversely impact the strength if some segregation and bleeding is going to happen. Okay, so we are definitely preferring to use the whatever the water is to cement ratio you have calculated in your concrete mix design procedure. Now, in the water is to cement ratio, it is important for us to study the definition also, because this definition was asked in many of your competitive examination. You can copy that also. What is water is to cement ratio? So water is to cement ratio is defined as the ratio of weight of water added at the time of mixing. What is water is to cement ratio? Weight of the water added at the time of mixing to the weight of cement in a given mix. To the weight of cement in a given mix. Okay, this definition was asked previously in competitive exams as well as in your online MCQ test. Okay, so water is to cement ratio, as I told you, it is nothing but the ratio of weight of water that you have used or that you have added at the time of making that concrete mix with respect to the weight of cement. So water cement is generally expressed as a volume of water required per 50 kg of cement. What is water? How we are going to describe it? Water cement ratio or the water cement content in a given concrete is generally expressed as volume of water required per 50 kg of cement. Okay, or per bag of cement, you can call it as. So concrete achieves its strength due to its chemical reaction that everyone knows, heat of hydration process is there. So your water is to cement ratio will make a big impact in gaining the strength. If you use the water is to cement ratio as per your mix design calculation, then definitely you will get more strength. But if you do some malpractice regarding the water is to cement ratio, okay, if you have taken wrongly, then definitely it will adversely impact the strength of your given concrete. Okay, adversely impact the strength of the given concrete. So the compressive strength of concrete, it depends upon the water is to cement ratio. Lower will be the water is to cement ratio, higher will be the strength, and vice versa. Always remember that. Okay, that is why we are always recommending to use the water is to cement ratio that you have calculated. आता तुमच्या डोक्यामध्ये हा प्रश्न पडला असेल, सर हाउ वी आर गोइंग टू कॅल्क्युलेट द वॉटर इज टू सिमेंट रेशो. सो इन युअर चॅप्टर नंबर 7 I will give briefs about how to calculate, in brief information about how to calculate the water is to cement ratio. The procedure has been set up and it has been given in our IS 10262/2019. So there you will come to know how to calculate the water is to cement ratio. Okay, preferably just keep the thing in the mind. The water is to cement ratio, the best you can take it is from 0.38 to 0.45. Okay, based on the experience that I'm telling you, it is again going to vary with respect to the different grades of the concrete. Otherwise तुम्ही म्हणताल नाही सर तुम्ही असं म्हटले होते. ठीक आहे. Water is to cement ratio, that is the first point which will make an impact on the gaining the strength. Second one is nothing but the I can say the gel space ratio. Okay, what is the gel space ratio and how it is important for us to understand. Okay, what is gel space ratio? So gel space ratio is a better approach than that of your Abrams law. There is one law which has been stated and which gives you relation between the strength of the concrete and your water is to cement ratio. At this time we are not going to focus on that law, but gel space ratio is very important for us to understand. Okay, so gel space ratio, basically which factors these are going to consider. So it is going to consider the degree of hydration of the cement, chemical and physical properties of the cement, the temperature at which hydration takes place, the air content in case of air entrant concrete, and effective water is to cement ratio. So what is the gel space ratio and how these factors like your degree of hydration, then chemical and physical properties of your cement, then temperature at which hydration is going to take place, how it is going to affect the particular strength of the concrete. If you read the definition, you will get more clear idea. It has been mentioned. I will use the highlighter for the same. As you can see, the definition is written over here. What is gel space ratio? It is the ratio of volume of the hydrated cement paste. It is the ratio of volume of hydrated cement paste to the sum of volume of the hydrated cement paste and the capillary pores. That is why it is important for us to understand this concept, gel space ratio. Okay. One by one point I will take it. The volume of your hydrated cement paste. As everyone knows, when you are going to add some quantity of the water, what will happen in a cement paste, in a given cement? Hydration process will start, correct? What is hydration process? It will get liberated and concrete or your cement particles will start gaining the strength, correct? So in gel space ratio, it is nothing but the ratio of the hydrated cement paste. Ratio of hydrated cement paste to the sum of volume of hydrated cement paste plus capillary pores. Now, during the hydration process, as I told you, heat is been liberated. So what will happen if there are, suppose, just take one example, okay, for your understanding. Suppose the percentage of air voids or the percentage of voids in a given cement particle is suppose 10% initially. Now you have added the water, heat of hydration process has started. What will happen? Due to the hydration process, cement will directly start gaining the strength, correct? It will harden, try to harden. So during this phase, whatever the voids are there, these voids also going to play a vital role in hydration process as well as in gaining the strength. Okay. Definitely there are some voids which have been present in the cement particles. So what is gel space ratio tells us? Gel space ratio is nothing but the ratio of your volume of your hydrated cement paste. Hydrated cement paste. Please underline this particularly. To the sum of volume of your cement paste plus volume of your capillary pores. As I told you, there are some pores which have been present in the cement particles also or in your concrete body. So we have to consider that gel pores also. Okay. Because if that spores are get filled with some material, it may be your cement, it may be your supplementary cementitious material, or it may be any other material, filling material. What will happen? The air void percentage goes on decreasing. If the percentage of voids goes on decreasing, definitely concrete will gain more strength. Concrete will gain more strength. That is why it is important for us also to understand this gel space ratio. Okay. It is important for us to understand this gel space ratio. And if there are more voids in a given concrete, what will happen? Right? Concrete is going to gain the strength, but on the lower side because of presence of more voids. Okay, honeycombing तुम्ही बघितलेलं construction site वरती. Honeycombing is not the right example, but still for your understanding, I am telling you. ठीक आहे. तुम्ही honeycombing बघितलं. Honeycombing म्हणजेच काय रे? कुठेतरी तुम्हाला सिमेंट पार्टिकल दिसतात, सिमेंट आणि मॉर्टर दिसते, कुठेतरी खड दिसते, कुठेतरी voids मध्ये स्पेस दिसतो. Okay, they are not properly bonded together. It may be any reason. So, if they are properly bonded, what will happen? The weight of the concrete body goes on increasing. Self weight तुमची unit weight वाढणार आहे. Because of less voids percentage, the concrete is going to gain more strength. Okay, not completely going to feel all the air voids are get removed, but definitely we have to consider these capillary pores. Which will play again a vital role in your gaining the strength of your concrete. Okay, gel space ratio. So in the gel space ratio, as I told you, we have to consider the degree of hydration of cement. At what speed the hydration process starts, the hydration process continues. Okay, then chemical and physical properties of your cement. What are the physical properties of the cement? Like the specific gravity of your cement. Then what can I say? Water absorption, moisture content, then consistency, setting time, soundness, fineness, These are the some physical properties of the cement. Okay, so we are going to carry out the physical test, and based on that, you can suggest, yes, sir, the degree of hydration of this cement is very good. Okay, or these are the physical properties. Then temperature at which hydration takes place. Okay, again, this point also we need to consider air content in case of air entering agents and effective water is to cement ratio. All these make an impact in your gel space ratio, which is the one of the factor that we need to consider as far as your strength is considered. Okay, understood what is gel space ratio? Please do some response in the chat box so that I can proceed further. समजतंय का आधी हे सांगा. जेल स्पेस रेशो काय आहे समजला? Thank you for your quick response. So this is about the gel space ratio we have discussed. Now let us move forward for the next part, effect of size of coarse aggregate. Okay. Now how it is important for us to understand this phenomenon, that is nominal size of coarse aggregate or the size of coarse aggregate. As I told you, large size of coarse aggregate has a lesser surface area. Large size of coarse aggregate has a lesser surface area and it also requires less water to achieve the workability. Okay, it also requires less water to achieve the workability. Hence, lower water cement ratio can be used and high strength can be obtained. But there is one point which I need to address to you. Okay, with the large size of coarse aggregates, the internal bleeding may take place. There will not be any proper bonding, or there should not be any uniform distribution of the load throughout that concrete matrix. Okay, so that is why again the next part is very important for us to understand effect of size of coarse aggregate, my dear students. So what type of effect is going to make if you are using the large size of the coarse aggregate? See, as per our IS 10262/2019, for different whatever the some sizes of the coarse aggregates are mentioned, correct? You are going to use 25 mm size coarse aggregate, you are going to use for 20 mm size coarse aggregate, you are going to use 12.5 mm size coarse aggregate. Okay, you have the freedom, but you are going to cast a concrete of M20 grade. Now listen very carefully. Yeah? If you are going to cast a concrete of M20 grade and you are going to use 80 mm boulders for doing that, you are going to use boulders of 80 mm or maybe for 50 mm, 63 mm, what will be the nature of your concrete? Will it be workable? If it is workable, will it? Is there any bonding between your coarse aggregate and your rest matrix, that is your fine and cement and water, fine aggregate and cement and water? So we need to address such questions also. Okay. That is why it is very important for us to have the knowledge about the nominal size of coarse aggregates that we are going to use in our concrete construction. Okay. Generally, in most of our construction sites, we are using a concrete of M20, M25 grade. In case of your buildings, maybe M30 in some cases. Okay, but in case of road construction, where we going to use M20, M30, 40, 50, 60. Okay, for high-rise buildings or big projects. Okay, again up to M50, 60. That grades of the concrete we are going to cast. But if you are generally in our construction sector, like for your houses, buildings, we are generally using M20, M25 grade of concrete or M15 grade of concrete. And for that, if you are going to use boulder of 63 mm or 50 mm to prepare the concrete, as size of the coarse aggregates are more, there will be lesser surface area. There will be lesser surface area. And for the lesser surface area, we require the less water to achieve the workability. But on the other hand, due to the lesser surface area, there might be chance of no proper bonding between your coarse aggregate and rest of your cement concrete matrix. That is your fine aggregate, cement and water. That is why we need to select the proper size of coarse aggregate for preparing our concrete mix. If you are going to use the large size coarse aggregates to prepare a concrete mix, then definitely you have to keep focus on its workability, on its bonding, that is bonding of coarse aggregate with the rest of the concrete matrix. We need to consider that once. Okay, then distribution of the load. As you are using the large size of coarse aggregates, definitely you are going to face the problem of honeycombing also. Okay, so that is why we have to select the proper size of coarse aggregate. I'm not going to suggest no, you have to only use 10 mm size coarse aggregate. That parameters are different. Which type of coarse aggregate we need to select? What is the size of coarse aggregate that we need to select? We can discuss that parameters in our chapter number 7, that is in concrete mix design. But right now, for your understanding, please remember the size of coarse aggregate will make a big impact on the gaining the strength of the concrete. Okay. If you are using larger size coarse aggregate, definitely you will face the problem of non-uniformity distribution of the load. Definitely you are facing the problem of bleeding or the segregation, which may happen. Okay. As I have given you the example, for M20, you are using 63 mm boulders. Does it make any sense? You can do the concreting by using that coarse aggregate, but you have to look after for its properties, like maybe the segregation, maybe the bonding between the coarse aggregates and the rest of the concrete matrix. Okay, but if you use the relevant smaller size coarse aggregate particles, like for M20 or M25, you are using 20 mm size coarse aggregate, you are using 12.5 mm size coarse aggregate, you are using 10 mm size coarse aggregate, definitely you can achieve that much of strength, that much of durability which you are expecting. Okay, because particle size is smaller, so greater surface area. If there is greater surface area, there will be very good bonding. The same rule applicable in case of cement also. Cement rule is applicable in case of coarse aggregate also. In cement, I think in my first unit, I have told you how the bonding works. If the cement particles are finer one, that is why fineness test is very important for us to understand the concrete phenomenon, because finer will be the cement, more will be the greater surface area, and more will be the greater surface area, there will be more proper bonding between the cement and rest of the concrete particles. Okay, that is why we are preferring the finer cement. Okay, we are preferring the finer cement. The same rule applicable to coarse aggregate also. If finer size of the coarse aggregates are using, finer means they are not less than 4.75 micron size. Okay, otherwise you can call no sir 2.36 mm size आम्ही coarse aggregate. That is not coarse. It's a fine aggregate. Okay, कुठली relevant with respect to your mixed design, with respect to the grade of concrete, you have to select the proper size of coarse aggregate. Okay, so for M20 or 25, you are suppose you have taken maybe 25 mm size coarse aggregate, 20 mm size coarse aggregate, 12.5, it is okay. Okay, that particle having particle size is smaller, it provides greater surface area to have the proper bonding between your coarse aggregate and the rest of the concrete particles. Okay. So again, effect of the size of the particles, we need to consider as far as gaining the strength of the concrete. Okay. The next part, though it is not for you, but still I can take it for you. That is the maturity part or maturity concept of the concrete. Maturity of the concrete. Concrete kadi mature hota. Okay. It's very interesting part. Everyone knows for human beings, maturity comes by with respect to age only. Correct? Now you are 16 plus, maybe you are 18 plus. Okay. Now everyone considered you as a matured one. Not know exactly whether you are fully matured or not, but still, people surrounding you, they assume, yeah, you are 16 plus or you are 18 now. तुम्ही आता मोठे झालात बोलतात असतात. मोठे झालात म्हणजे तुम्ही समजूतदार आहात. You are matured person. Correct? कसे आले रे ती maturity? Maturity comes with the age. For human beings, I am giving you the example. Correct? Maturity comes with the age or with the experience. ठीक आहे. आपल्या भाषेत आपल्याशी जर बोलायचं झालं तर. In case of cement, in case of concrete also, we need to consider the maturity concept. We need to consider the maturity concept. What is maturity of concrete? The concrete is the maturity of the concrete is nothing but the relation between its time and temperature. So the product of the whatever the product of time and temperature, we can call it as the maturity of the concrete, because the concrete is going to gain the strength, okay, with respect to some time. It requires some time to gain the strength. Correct? It requires some time to gain the strength. It may be 10 days, 7 days, 3 days, 28 days, 60 days, 90 days, 120 days, whatever the time it is going to take. But concrete requires some time to gain the full strength. Correct? And during this phase, during this journey, the temperature conditions will remain constant? Definitely not. It may happen that on the day of concreting, the temperature is around 27 degrees. On the second day after concreting, second day of concreting, the temperature may be 30 plus. Third day, temperature may vary. Let it comes to directly 25. It has dropped down. Again, on the fourth day, the temperature is around again 32 degrees centigrade. So whether the temperature conditions are remain constant? No, definitely not. So what is maturity of the concrete? So maturity of the concrete is expressed as the function of summation of the product of time and temperature. Summation of the product of time and temperature. Because increase in the strength of the concrete is not only depends upon the curing period, but it also depends on the temperature at which concrete is cured. Okay, that is why again I am repeating my sentence. It is recommended to use the air conditioning system in case of your concrete technology. Okay, it is recommended to use the air conditioning system. Why to use the air conditioning system in the concrete technology lab? Sir, आम्ही घरामध्ये बसवत नाही, आम्ही लॅब मध्ये का बसवायचं? Because with the help of that air conditioning system, you can maintain the required temperature. That is very essential part for the concreting to cure, to gain the strength. Suppose you require temperature range 25 to 27 degree. With the help of AC, you can maintain that. Okay, with the help of AC, you can maintain that. For the relative humidity that is required, again, you can maintain that with the help of the AC. Okay, so increase in the strength, as it is been mentioned, it not only depends upon the curing period, but it also depends upon the temperature at which your concrete structure get cured. Okay, so that is why this maturity concept also you must be familiar with. Okay, so another important information regarding this, the hydration of the concrete is continued up to minus 11 degrees centigrade. Okay, that is why minus 11 degrees centigrade is considered as the datum line for calculating the maturity of the concrete. So your matured concrete can gain the strength at a temperature of minus 11 degrees centigrade also. Now you just imagine how magical our concrete is. Okay. It can achieve the strength at 40 degrees centigrade also, and your hydration process, whatever the hydration process which is going to happen in the concrete, it may last long, or it may going to happen at a temperature of minus 11 degrees centigrade. So that is why in our concrete sector, the minus 11 degrees centigrade is the temperature, that is the datum line for gaining or for calculating the maturity of the concrete. Okay. Now one example is there. Please remember this also. Concrete cured at 18 degrees centigrade for 28 days is considered to be fully matured. कधी mature होते बघा. Concrete cured at 18. Now it is 25 to 27 degree. That is at standard room temperature. You just remember. जर तुम्हाला temperature ची range आठवली नाही, standard room temperature you can remember. So concrete can cured at a standard room temperature conditions for 28 days is going to be considered as a fully matured concrete, and its maturity is calculated as, how it is calculated, 28 days multiplied by 24 hours, that is in a single day you are having 24 hours into now this is the, what is this is nothing but the time, correct? 28 days 24, and in a single day we are having 24 hours, correct? Now, second, what is the formula for calculating the maturity? It is nothing but the summation of product of time and temperature. Now, time we have taken, that is 28 days. In single day, we are having 24 hours. That is by 28 into 24. Multiplied by second product. Concrete is cured at a standard room temperature. It may be 18 or it may be 20, it may be 25 degrees centigrade. So 18 minus, what is the datum line for our concrete maturity? It is minus 11 degrees centigrade. So 18 minus 11 degrees centigrade. Okay. So if you just take this product, that answer is, I think 19,488 degrees centigrade per 19,488 per degree centigrade hour. Okay. So that is the value of the maturity of the concrete. Okay. Now, if the 28 days strength of the concrete is known, then strength of concrete at any other maturity can be found by Plomin's equation. Okay, the relation is given: compressive strength S equals to A plus B log to the base 10 of into bracket maturity divided by 100, where A and B are the Plomin's constant, which depends upon the 28 days strength. This part is not there, just additionally I am telling you. You please remember this part. Maturity of the concrete. Okay, what is this maturity? It is nothing but the product of, summation of product of time into temperature. What is the datum line for achieving that maturity of the concrete? Minus 11 degrees centigrade. Okay. Then effect of age, very simple, as with respect to the age of the concrete, definitely the strength of the concrete, it may happen that it goes on increasing. In most of the cases, it goes on increasing. In some cases only, with respect to age, the strength of the concrete goes on reducing. If you are doing some malpractice, okay, you have not properly cured, you have not properly designed, or you have not properly executed your concrete, okay, then in that case, it may happen that your concrete can lose its strength. But with respect to the effect of the age, maybe in just first 6 months, first 1 year, 2 years, concrete is going to gain the strength. Hydration process is a process which lasts long in the concrete body, correct? So concrete develop the strength due to the hydration of our 4 bogies compounds, you know very well, that is C2S, C3S, C3A, and C4AF. Okay. It also depends on the rate of heat of hydration, which may occur in the particular concrete body. Okay. So increase in the strength beyond 28 days and up to 1 year is of the order of 10 to 20%. बघा कसं वाटतं? Is of the order of 10 to 20%. म्हणजे निश्चितपणे जसं तुमचं कॉन्क्रीटचं एज होतंय, ठीक आहे, एखादी इमारत आहे 6 महिने जुनी आहे, 1 वर्ष जुनी आहे, 2 वर्ष जुनी आहे, त्या फेज मध्ये it may happen that it is going to gain the strength. Okay, but if you do the malpractice, remember it is definitely going to lose the strength. Okay, So with respect to age, we need to consider the strength of the concrete. Again, it will make good impact in gaining the strength. But if you do some malpractice, definitely it will make bad impact. Okay. Then fineness of the cement, as I told you, finer is the cement, more will be surface area. If there will be more surface area, definitely there is a good bonding between your cement and rest of the concrete matrix. So particle size, suppose 5 to 7 micron, contributes of the strength of the concrete at the edge of. ठीक आहे, काय कॉन्ट्रीब्युशन किती दिवसात कॉन्ट्रीब्यूट करतोय? 5 ते 7 मायक्रॉन जर साईज असेल पहिल्या 1 ते 2 दिवसामध्ये. ठीक आहे. सो फायनर पार्टिकल साईज आहे, स्ट्रेंथ खूप लवकर अचीव होणार आहे. 20 to 25 microns 7 days, 25 to 30 microns 28 days. Okay. This part I think I have explained. Now development of strength, it also depends upon the water is to cement ratio. This graph is there for you for your understanding purpose. Okay. Development of strength based on the water is to cement ratio. Okay. जितका water is to cement ratio जास्त असणार आहे तितकं तुमचं कॉन्क्रीट स्ट्रेंथ गेन कमी करू शकतं, आणि जितका water is to cement ratio तुमचा लो असणार आहे कॉन्क्रीट is going to achieve higher strength. Please remember this simple concept. If you are dealing with the low water is to cement ratio, ठीक आहे, low means it is not like that सर मी 0.1 च घेतला water cement ratio किंवा मी 0.2 च घेतला without any admixture, this concrete तुमचं कॉन्क्रीट होणारच नाही. इट्स अ हार्श कॉन्क्रीट देन आय कॅन से. ठीक आहे. आपल्या कॉन्क्रीट टेक्नॉलॉजी मध्ये एक फंडा आहे, वी कॉल्ड इट एज हार्शनेस ऑफ द गिवन कॉन्क्रीट. व्हॉट इज हार्शनेस? हार्शनेस इज नथिंग बट अब्सेन्स ऑफ वर्कॅबिलिटी. काय असतं, जसं सेग्रिगेशन तुम्ही शिकलात, जसं तुम्ही ब्लीडिंग किंवा लेटेन्स शिकलात, तसं अजून एक टर्म ही लक्षात ठेवा, हार्शनेस ऑफ कॉन्क्रीट. HARSH, harshness of the concrete. What is harshness? Harshness is nothing but the absence of workability. Okay, absence of workability means concrete मध्ये काहीच नाही, एकदम झिरो वर्कॅबल आहे, झिरो स्लम कॉन्क्रीट आहे. म्हणजे जसं कोन मध्ये टाकलं तुम्ही स्लम कोन मध्ये टाकता ना कॉन्क्रीट वर्कॅबिलिटी काउंट करण्यासाठी. सपोज स्लम कोन मध्ये कोन लिफ्ट केलाय, जसा कोनचा शेप आहे तसंच कॉन्क्रीट राहिलं का? झिरो स्लम, पाणी खूप कमी आहे, खूप म्हणजे जरा जास्तच कमी झालं, असं पण करून चालणार नाही आपल्याला. ठीक आहे. सो कॉन्क्रीट मस्ट बी वर्केबल, having some low to moderate or moderate to high workability. Okay. No, if temperature is more, we are having some water absorbing agents, we are having some super plasticizers or the plasticizers which will help us to maintain the workability of the concrete without compromising, sorry, by compromising on water cement ratio, by reducing the water cement ratio also, or by keeping it the same. Okay. So please remember very simple part. You please take the water cement ratio as you have designed it or as you have calculated or it is recommended. Okay. Don't go for more water cement ratio. What I have seen, one example I will tell you. For 1 meter cube, for maybe the one project I have done and what I have seen, they have used 1 bag of cement. किती cement use केले? 1 bag of cement. Okay, and for that 1 bag of cement, literally they have added 25 to 28 liters of water. Okay, 25 to 28 liters of water. You just imagine, cement जर 50 किलो आहे आणि त्याच्यामध्ये 25 लिटर पाणी, म्हणजे वॉटर सिमेंट रेशो 0.5 इथेच झाला तुमचा. ठीक आहे. How the concrete will become? It is more or it is highly workable concrete. Okay, so it is recommended to use the designed or calculated or the minimum water cement ratio as far as possible. Minimum म्हणजे इतका पण minimum नाही की तुमचं concrete completely harsh होईल. It is, we require the concrete having some workability. So you have to select that water cement ratio. Okay, again as I told you, we will take this part in our chapter number 7, how to calculate the water cement ratio exactly for the whatever the concrete mix that you are interested to prepare. Okay. The next part is a stress strain curve. I think stress strain curve, I think you are very much familiar about the stress strain curve. Have you can you have some brief insights about the stress strain curve of the steel? Stress strain curve of the steel. What is Hooke's law? What is Hooke's law? Again, I will repeat the definition. I want to repeat my question.
Within a elastic limits, stress is directly proportional to strain.
This is the ratio of the stress is to strain within the elastic limit. Okay, that is your Hooke's law. But what is limit of proportionality? What is limit of proportionality? Very simple question I have used. What is limit of proportionality? Within elastic limit, stress is directly proportional to strain. Very simple question. Just I have twisted the question which previously I have asked. Okay. Hooke's law is what, at limit of proportionality is what? Okay, chalo, very good answer. Who has given this answer? Anisha. Okay, good. Chalo. Then what is ultimate load? What is the ultimate load? What is the yield load? Two definitions you have to give the answer for this. What is yield load and what is ultimate load? What is yield load? What is ultimate load? Please define. Who will tell me what is ultimate load? What is yield load? I will give you 2 minutes, 2 to 3 minutes. Very good, Mayur. Maximum load carried by the material before its failure. Okay. Maximum load which is carried by the material before its failure. That is nothing but your ultimate stress. What is yield stress or yield load? Take 2 minutes to think on this question and then give me answer.
Extension in rod increases, but the load decreases.
Take 2 minutes, think on it, and tell me the definition. I know it is, I just want to check how many of you know the concept of yield load and why it is important for us to consider it. Please do respond fast. What is that yield load? I know we have two yield points, that is lower yield point and upper yield point. But what is that yield load? Maximum deformation in small loading. Extension increase the load is decrease is called a breaking stress or stress at failure. I have asked you what is yield load. Okay. The condition at material offers the resistance to the greater extension. The stress is also called as lower yield point. What is the condition? Can you tell me the condition when yield load is achieved? Okay, whether load is going to increase and whether the load is going to be increased with respect to the time, with respect to the displacement. A bar of material is the maximum stress. Yield load is a behavior to the plastic material deform elasticity and gets after removal, coming back to its original shape. Okay. Take your time up to tomorrow and tell me the exact correct definition. Okay, what is yield load and how it is playing the role in case of your reinforcement. Okay, now let us discuss with a stress strain curve which we are going to consider in our concrete. Okay, now in our concrete it is very simple concept to understand. See, in case of your compressive strength, what will be the nature of stress strain curve? So up to 30% or stress up to the 30%, the 30% of your ultimate strength, the transition zone cracks remain stable and the stress strain curve or whatever the stress strain curve we are going to draw now, it remains linear. It remains linear. Okay. The stress between 30 to 50% of your ultimate strength, the transition zone micro cracks begin to increase in length and width or in the numbers. Okay, so the stress strain plot becomes non-linear. At between 50 to 60% of this ultimate stress, the cracks began to form in the matrix. With further increase of about 75% of the ultimate stress, the cracks in the transition zone becomes unstable. Okay, and likewise, the formation of the cracks are there. Okay, as you can see, some stages are there. Typical stress strain diagram is there for the concrete. Okay, now you just see the first diagram, the pointer which I am scrolling. एक कॉन्क्रीटचा ब्लॉक आहे, ठीक आहे, मराठीत सांगतो म्हणजे खूप चांगल्या पद्धतीने लक्षात येईल तुमच्या. एक कॉन्क्रीटचा ब्लॉक आहे, कॉन्क्रीटच्या ब्लॉकवरती, ठीक आहे, कम्प्लिटली हार्ड आहे आणि त्यावरती तुम्ही लोड अप्लाय केला, ठीक आहे. जर तुम्ही त्याच्यावरती कमी लोड अप्लाय केला त्याला काही इफेक्ट होऊ शकतो का? होणार, बट व्हेरी मायनर. ठीक आहे, जर तुम्ही 30% ऑफ इट्स अल्टिमेट स्ट्रेस, सपोज त्या कॉन्क्रीटची स्ट्रेंथ जी आहे ती सपोज 30 न्यूटन पर एमएम स्क्वेअर आहे. किती आहे? 30 न्यूटन पर एमएम स्क्वेअर. ठीक आहे, ही त्याची मॅक्सिमम किंवा अल्टिमेट लोड कॅरिंग कॅपॅसिटी आहे त्या कॉन्क्रीट ब्लॉकची. ठीक आहे, आणि तुम्ही त्याच्यावरती फक्त 10 किलो न्यूटन किंवा 7 किलो न्यूटन इतका लोड अप्लाय केला. ठीक आहे, 7 न्यूटन पर एमएम स्क्वेअर किंवा 7 न्यूटन इतका लोड तुम्ही किलो न्यूटन इतका लोड तुम्ही अप्लाय केला. ठीक आहे, म्हणजे जस्ट असं अज्युम करा की तुम्ही त्याच्या फक्त 30% ऑफ द अल्टिमेट स्ट्रेस अचीव झालेला आहे. 30 ही तुमची कॉम्प्रेसिव्ह स्ट्रेंथ होती, अल्टिमेट स्ट्रेस होता, त्याच्या 30% म्हणजे अबाउट 9. ठीक आहे, अबाउट 9 MPa एवढी स्ट्रेंथ अचीव केलेली. त्या कॉन्क्रीटमध्ये तुम्हाला व्हिज्युअली कुठं क्रॅक्स दिसतील का इतक्या कमी लोडिंगला? डेफिनेटली नाही, तेवढ्या कमी स्टेजला, इनिशियल स्टेजला. पण जसजसा तुम्ही लोड वाढवताल, जसजसा तुम्ही लोड वाढवताल, आधी 5 किलो होता, मग 10 किलो केला, 15, 20, 25, 30, 50, जसं तुम्ही कॉन्क्रीट वरती ते लोडिंग वाढवताल तस तसं काय होणार आहे? तर कॉन्क्रीट मध्ये जे काही क्रॅक्स पडणार आहेत ह्या लोड मुळे, हे क्रॅक्स काय होणार आहेत, सुरुवातीला ते लिनियर होते, त्यानंतर ते नॉन लिनियर फेज मध्ये जाणार आहेत, म्हणजे क्रॅक्स काय होणार आहेत, वाढत जाणार आहेत, जसं तुम्ही डायग्राम मध्ये बघू शकता. ठीक आहे, पहिल्यांदा कुठल्याही क्रॅक्स नव्हते, मायक्रो क्रॅक्स आहेत, खूप मायक्रो क्रॅक्स होते कॉन्क्रीट बॉडीमध्ये 50%, म्हणजे जसा लोड वाढला अजून तसे ते मायक्रो क्रॅक्स काय व्हायला लागले, मॅक्रो क्रॅक्स मध्ये कन्वर्ट व्हायला लागले, म्हणजे वाढायला लागले. 75% ऑफ अल्टिमेट लोडला अजून त्यामध्ये व्हायला सुरुवात झाली. ते क्रॅक्स अजून लॉंग, म्हणजे त्याची विड्थ वाढली, त्याची लेंथ वाढली, त्याचे नंबर्स वाढले क्रॅक्सचे, आणि एक पॉईंट असा येतो की जिथे तुम्हाला सगळे क्रॅक्स दिसतात. सो दिस इज व्हॉट दिस स्ट्रेस स्ट्रेन कर्व इज ऑल अबाउट. If you just see the diagram, phases are there, phase number 1 2 3 4. पहिल्यांदा हा ग्राफ काय होता रे, लिनियर होता, ज्याला तुम्ही आपल्या रेन्फोर्समेंट मध्ये तुम्ही शिकलेला स्ट्रेस स्ट्रेन कर्व ऑफ स्टील, लिमिट ऑफ प्रोपोर्शनॅलिटी, बरोबर आहे. इट ओबेज द हुक्स लॉ, स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू स्ट्रेन. ठीक आहे, दिस कर्व अप टू 30%, दिस कर्व इज linear up to 30% of its ultimate stress. 30 to 50 it starts going to become non-linear. Okay, 30 to 50 मग हे जसे जसे क्रॅक वाढतील तसा हा काय होणार आहे, अजून नॉन लिनियर होत जाणार आहे, आणि असं कुठेतरी तो ब्रेकिंग पॉइंट वरती येणार आहे. सो दिस इज द स्ट्रेस स्ट्रेन कर्व फॉर युअर कॉन्क्रीट. प्लीज डू रिमेंबर दिस 4 थिंग्स: stress up to 30%, stress up to 50, 75 or 100% strain with respect to the strain. Stress against strain curve. ठीक आहे, क्लियर आहे सर्वांना स्ट्रेस स्ट्रेन कर्व, समजला? ओके, सो दिस इज अबाउट द स्ट्रेस स्ट्रेन कर्व ऑफ द कॉन्क्रीट. Then okay, a very important part, that is tensile strength. Then you are this bond strength, shear strength, flexure strength. This is the rest part of this particular chapter, I think. Yes, is there. And grades are there. Yes. So continuing with the next part. Tensile strength, I think compressive strength you all are aware how we are going to calculate the compressive strength, but still if you are not aware, I will explain you how we are going to check the compressive strength of the given concrete. Okay, so for checking the compressive strength of the given concrete, we are going to use the concrete cubes. What we are going to do, we are going to use the concrete cubes. Now what is the size of the concrete cube? The size of the concrete cube is 150 by 150 by 150 mm. What is the size of concrete cube? It is 150 by 150 by 150. Okay, mm. एक कॉन्क्रीट जो ब्लॉक असतो ते किंवा तो कॉन्क्रीटचा जो मोल्ड आहे, स्टँडर्ड मोल्ड ज्याला म्हटलं जातं, त्या स्टँडर्ड मोल्डची साईज असते 15 सेंटीमीटर बाय 15 सेंटीमीटर बाय 15 सेंटीमीटर, म्हणजे लेंथ, विड्थ आणि हाईट, किंवा 100 बाय 100 बाय 100 हा सुद्धा तुम्ही दुसरा ब्लॉक घेऊ शकता. ठीक आहे, हा no, that is different, that is for cylinder. Okay, so please do remember, for concrete blocks, to check the compressive strength, the size of the cube mold is 15 centimeter by 15 centimeter by 15 centimeter, the length, width and the height. Okay, so what you are going to do, how you are going to check the compressive strength? कशी चेक करणार आहात compressive strength? For checking the compressive strength of the given concrete, you are going to prepare the concrete mix as per the design that you are interested. Okay, that means you have to prepare a concrete of M10 grade, M15 grade, M20 grade, M25 grade or M30 grade. Okay, so with respect to the mixed proportion that you have, you are going to prepare the concrete. Okay, and then after preparing the concrete, you are going to fill the concrete in this concrete cube. You are going to fill this concrete in this concrete cube. How you are going to fill it? You are going to fill this concrete in the concrete mold or concrete cube in 3 different layers by giving 25 blows to each layer. कसा भरायचा ब्लॉक तुम्हाला थोडं थोडं भरायचं आहे. आधी 1/3 पोर्शन, नंतर 1/3 पोर्शन, त्यानंतर 1/3 पोर्शन. ठीक आहे, अशा 3 टप्प्यांमध्ये आपण तो ब्लॉक भरणार आहोत. ठीक आहे, ब्लॉकची साईज किती आहे? 15 centimeter by 15 centimeter by 15 centimeter. Okay. In 3 layers, we are going to fill the concrete by giving 25 blows to each layer. प्रत्येक वेळी आपण टॅम्प करायचं त्या कॉन्क्रीटिंग मध्ये 25 वेळेस टॅम्पिंग करायचं एका लेयरला. ठीक आहे. त्यानंतर त्याच्यावरती दुसरा लेयर टाकायचा आणि टॅम्प केल्यानंतर वन्स यू फिल द कॉन्क्रीट इन द कॉन्क्रीट क्यूब for 24 hours you are going to keep it in as it is condition. ठीक है. You are going to keep that concrete mold in as it is condition. ठीक है. Before keeping that, if required, you can give compact slight vibration to the concrete. ठीक है. To just level the surface of that mold, you can give slight some amount of vibration to this particular mold. So if required, if you have done the compaction correctly, then there is no need. But if you feel that no, the concrete must get compacted in the concrete cube mold, then you can use the vibrating table. There you can put your concrete cube block or on that particular table. You can just vibrate it for just 1 to 2 minutes maximum. Because if you do more excess vibration, what will happen? There is a chance of segregation and the bleeding. Okay, so you are going to keep your concrete blocks on that vibrating table just for 1 to 2 minutes if you require the compaction. Okay, then after finishing the level and all that, you are going to keep the concrete block, maintain the concrete block as it is in condition for 24 hours. For 24 hours. After 24 hours, you are going to remove the plates of that mold. That is, you are going to demold it. Whatever the concrete block you are having, you are going to remove the plates of that mold, and there you can see the concrete block is there of size. आता ते 15 बाय 15 बाय 15 सेंटीमीटरचा साचा होता, म्हणजे तुमचा कॉन्क्रीटचा ब्लॉक होता. त्यामध्ये तुम्ही कॉन्क्रीटिंग भरले म्हणजे त्या ब्लॉकची साईज सुद्धा किती असणार आहे? 15 सेंटीमीटर बाय 15 सेंटीमीटर बाय 15 सेंटीमीटर. देन दिस concrete blocks, you have to cure these concrete blocks in a water tank. You have to cure this concrete block in a water tank. Okay. For how many days you are going to cure it? Basically, you have to cast 9 blocks for any grade of concrete. For testing or for sampling purpose, at least you have to cast 9 blocks. Out of that 9 blocks, 3 blocks you are going to test on the 3rd day. Remaining 6 or 3 whatever the 6 blocks are remained. Out of that 6 blocks, 3 blocks you are going to test it on at the end of 7 days, and the remaining 3 blocks you are going to test it at the end of 28 days. Okay, and there you are going to check the compressive strength. How you are going to check it? आता हे जे काही क्यूर केलेले मोल्ड आहेत ना, 28 दिवसापर पाण्यामध्ये ठेवतो. काही ब्लॉक 7 दिवसांसाठी ठेवतो, काही ब्लॉक 3 दिवसांसाठी. किती ब्लॉक? 3 दिवसांसाठी 3 ब्लॉक, 7 दिवसांसाठी 3 ब्लॉक आणि 28 दिवसांसाठी 3 ब्लॉक. ठीक आहे, कारण आपण 3 ब्लॉक टेस्ट करतो आणि त्याची ऍव्हरेज व्हॅल्यू घेत असतो नेहमी सॅम्पलिंगसाठी. ठीक आहे, त्यासाठी आपण 3 ब्लॉक प्रत्येक 3 डे साठी 3, 7 डे साठी 3 आणि 28 डे साठी 3 असे एकूण 9 ब्लॉक कास्ट करतो. मिनिमम बोलतोय हे मिनिमम. ठीक आहे, हे ब्लॉक तुम्ही क्यूर केल्यानंतर सपोज 28 दिवस पूर्ण झालेले आहेत, मला स्ट्रेंथ त्याची मोजायची आहे. मी कशी मोजणार आहे? सो यू आर गोइंग टू टेक आउट दॅट ब्लॉक फ्रॉम द वॉटर टँक and keep it for a while. Okay, directly open to the temperature conditions. Okay, after that you are going to keep that particular concrete block in compression testing machine. Where you are going to keep it? You are going to keep that concrete block in compression testing machine. In that you are going to apply the load, and there you can see how much load it has taken by that concrete block. At one time, the readings goes on increasing like 5, 10, 15, 20, 25, 20, 30, 35, 40, 45, 60. And once it has achieved its ultimate load or the maximum load, okay, once the capacity is over, ठीक आहे, आता लोड घेऊ शकतच नाही, आता खूप त्याची एक स्वतःची कॅपॅसिटी आहे, त्यांना तितका लोड घेतला. ठीक आहे, सपोज 60 किलो न्यूटन द लोड इट हॅज टेकन. देन वन्स त्यानंतर जेव्हा त्याची कॅपॅसिटी संपणार आहे, ठीक आहे, डायरेक्टली द रिडिंग्स आर गेट रिव्हर्स डाऊन. मग ते रिडिंग कमी व्हायला सुरुवात होणार आहे. ज्या पॉइंटला तुमची रिडिंग कमी होते दॅट इज इट्स अल्टिमेट लोड. किती लोड घेतला होता म्हणजे 120 पर्यंत गेला आणि त्यानंतर परत रिव्हर्स झाला सर, कारण तो ब्लॉक फुटला, कम्प्लिटली ब्रेक झाल्यामुळे तो रिडिंग कमी कमी होत गेली. 120 पर्यंत गेला, त्यानंतर परत 110, 9 असे कमी झाले. ज्या पॉइंट वरती तो ब्रेक होणार आहे, जिथून तुमची रिडिंग रिव्हर्स होते, दॅट इज इट्स अल्टिमेट लोड, द अल्टिमेट कॅरिंग कॅपॅसिटी ऑफ दॅट कॉन्क्रीट ब्लॉक. Okay, so this load taken by the concrete block divided by its area, you will get the compressive strength. ठीक आहे, you will get the compressive strength. ठीक आहे, एरिया किती असणार आहे मग ब्लॉकचा, साईज किती आपल्या ब्लॉकची, लेंथ किती आहे, लेंथ आहे 15 सेंटीमीटर आणि त्याची विड्थ आहे 15 सेंटीमीटर. त्यामुळे त्याचा एरिया किती येणार आहे, 15 into 15, that is 225 centimeter square, or if you want to take it in mm, that is 22,500 mm square. ठीक है, basically we are calculating our strength of the concrete in Newton per mm square. Load is we are going to calculate in Newton, and area we are going to take it in mm square. So 150 mm by 150 mm, if you do the calculation, the answer becomes 22,500 mm square. ठीक है, so you have the load, that is the ultimate load, you have the area, so load divided by area, you will get the compressive strength of that particular concrete. You will get the compressive strength of that particular concrete. Hope you understand this. समजले सर्वांना what is compressive strength? Everyone getting how to calculate the compressive strength? As I told you, standard cubes of 150 by 150 by 150 mm size, we are going to use it. Okay, compressive strength कशी फाइंड आउट करतोय, समजले सर्वांना? Okay, others please do respond. Okay, then next part that is remain for this particular unit is tensile strength, flexural strength, and the different grade designation. Okay, but we will not take that part in our today's session, otherwise it will be overflowed for you. Okay, थोडंसं डोक्याच्या उठून जाईल. ठीक आहे, major part we have covered up. I think we just required next 2 hours. Okay, maybe 1 hour is sufficient for us. And by that we can finish our chapter number 4 also, and we can proceed for our chapter number 5. Okay, so probably next lecture we are going to finish our chapter number 4. Okay, the rest things from the chapter number 4 are tensile strength, then flexural strength, how it is calculated, relation between the flexural strength and the compressive strength, and effect of water is to cement ratio. Already we have discussed that part. Okay, and different grades according to the Indian standard IS 456/2000. Okay, grade designation, that part we are going to continue in our next upcoming session. So for the rest of this particular session, you can complete the assignment which has been there, and you can write down the notes also which I have been given to you. I think assignment I have shared, if you just check it.